And good morning, everyone. Thanks for patience with our little bit late. We had a couple of problems getting started, and here we are. I'm sorry?
We crossed the streams.
We crossed the streams?
Yep.
All right. Okay. Well, yeah. Well, okay. Anyway, I'm Kathleen Dollard, and I'm a PM on .NET Languages for Microsoft, and I'm very happy to be here today with my co-host, Bill Wagner.
Hello, I am Bill Wagner. I'm responsible for the managed languages content on docs.microsoft.com.
And who is this other person we have with us that I'm sure no one recognizes? I'm sure folks don't all know you. You're going to have to still introduce yourself. Don't expect.
Hi, my name's Jeff. I'm a Virgo. I like to write code and I take long walks on the beach. I do a couple little live stream things, broadcasts here and there. You might have seen me around.
Yeah. So we thought we'd bring Jeff in today to chat about, what it's sometimes challenging for me, at least, to still think like a in the trenches programmer. I was one up until 5 years ago, and I guess 6 now. Oh my gosh. And so, but it's still, I don't write code every day to get a job done. And Jeff spends a lot of time on streams talking to people that do exactly that and helping them to uptake our expanding world. And so I thought it'd be great, and we all thought it'd be great to bring Jeff on today to chat about exactly that and take your questions and see where we go in this pretty wide-ranging conversation. And we're really hoping for questions.
Can we go to the 3-camera scene where our 3 cameras are the same size next to each other? I don't have control of the things. And there we go.
There we are. I figured you were the guest, but it's okay.
I appreciate that, but I want to make sure.
A little too much, Jeff.
That's right. There's always great things that we hear when we talk to our communities, right? When we talk to folks on chat, and you out there, we're watching. We've got the chat panel up. We're absolutely want to hear what you're saying and what your thoughts are, because you're right, Kathleen. There's so much that's happening to push our languages forward, and I feel blessed to be able to say, literally, I can pick up the phone and call Bill and Kathleen or Mads and say, "Hey, I don't understand why this thing works this way. Can you help me out?" And you're right. There's to be able to keep up and follow those features can be a challenge, but what I also really like is you don't have to. Right?
Hopefully a couple of things you pick up new.
Well, sure. Right. Right. You can just take your project and turn on C# 11 or C# 12, and you don't have to use the latest features. Right. That's
That's right. That's
Yeah.
right.
And
On the run, go ahead, Bill.
I was going to say the other thing that I would say that I think is really important about that is it's not an either or switch, right? You can turn on C# 11, and anytime you think one of the new features is going to help you, use it.
Yeah.
But that doesn't mean I'm going to sweep all my entire code base and, use the latest features everywhere. That's time we don't have.
And one of the places I think that people can have trouble with is just straight off of the gate is we have too many numbers, and we do the best we can with having a lot of numbers. But just to remind you that C# 11 is what you are using today in full release. C# 12 is what we're working on for release in November. C# 11 coincides with .NET 7. C# 12 coincides with .NET 8. We have a lot of numbers. And so I just want to remind everybody of that.
Right. The language versions are roughly 4 ahead of the current .NET version.
Well,
right?
that's only C#. VB,
Right.
I think, is different, and F# is different too. So we have too many numbers.
F# matches. We're going to try to hold that line. It's kind of challenging, but we're going to try to hold the line of F# matching because we have too many numbers. And then Visual Basic was aligned with Visual Studio, but then as we stopped adding new features, which we've talked about in our strategy, then we've held the line. And I'm sorry, I can't remember whether it's 15 or 16 right now, but it is. I think it's 15. But just don't even include your language version, and you get the latest one that's supported on the framework of your project. So most of you don't even specify language version. You just say, my target framework is .NET 7 or .NET 8. Well, in the future, .NET 8. And then that brings in C# 11 or C# 12.
Mm-hmm.
I like this question.
Right. So that's our first question popped up there. So what is the most exciting new feature for all of you, I guess us, that helps with development?
I'm a big fan of pattern matching. Feature-wise, right? Language feature actually doing something. If you were to just ask me just all up feature in C# that we've added in the last 2-3 years, file scope namespaces, global usings, implicit usings. Get rid of all that boilerplate nonsense at the top of the files that is, I've got copied and pasted into every single C# file in my project. I love that. But that's kind of like, right, that's kind of a compiler trick. We're just moving things around. The using statement was here, but now it's over there. But pattern matching has given me new ways to think about writing my code. It's given me new ways to write some of the branching logic where it can get very clear on exactly where the branches are and hand things off. It particularly hand things off to other methods to go and do things, or to apply a formula and immediately set a value. And that terseness that it creates inside my code, I think, is something that makes it much more readable. And then it allows me to hide and move some of that logic to other places where I can start taking advantage of single responsibility principle and put those in other places where it's doing just that one thing, and I end up with a smaller method somewhere else. I like that a lot.
Yeah, I think that's great. And I think that pattern matching is actually really interesting too in how we build our application, build the language. It is, we have like an arc. Now we don't have like these huge releases with one big feature and everything else kind of gets lost in the mix. We have arcs, different arcs that are running. And the pattern matching arc, no arc is ever fully done, but there comes a point where we don't have anything we need compelling to do in this release, in which case I sort of feel like, well, it's calming down. And pattern matching is calming down. We don't have the pattern matching feature for C# 12. And it's the first release, I believe, since C#. Bill, can you help me out? 7 or 8? When we introduced it's been quite a while.
Pattern matching started with 7. In 7.
The very first pattern matching appeared in C# 7. So that's 5 years ago. So it's been quite a journey. And we kept adding more and more and more, including the list patterns that we added in C# 11. But now in C# 12, we don't have anything compelling to add. So we're going to take a break on that and work on some other things.
Mm-hmm.
Yeah. So as far as me, I'm going to kind of say the same thing. I'm going to go to Tanya's next comment, matching the data type itself or the data. Honestly, both. And as Fully Snowball points out, you can do both. And this is why I think pattern matching, to kind of agree, this is the biggest game changer. If you think of our branching logic before pattern matching, you could do one of two things. You could either do virtual functions and it was just based on the type and it was very, very, object oriented. I'm going to make derived classes and virtual functions, and that happens. But that was the only thing you could do. And then, or you could look at properties and write if, very imperative logic. If X is 3, do this. If X is 5, do that, and so on. What pattern matching does is it allows you to just kind of look at the shape of data, which is the fuzzy term we use for this to say, it's got certain characteristics. It's this type or something derived from this type, and this property has this, or the list has this many elements or whatever. And it becomes a very, very elegant way to say it's data that looks kind of like this, the way we would describe it in a human language. And then we can dispatch it to some method or whatever. So when can we do? I'm just watching the chat as this comes back too. So we get this one. I don't know. We can sort of now, I think. So you can do a match on a closed generic type, if I'm remembering correctly, but I don't think we can just match on the type parameter itself. But we can, there's some funky stuff you can do to get kind of close to it. So I may have to write some docs on that to show some of the workarounds for what you kind of want.
But what's the use case of that?
That was my question. I'd love to see
what is it
what we're trying to do there. Yeah.
Right.
And I would like to see an expansion there of what is it that you want to do with that one.
I've got a list of T inside of a generic class that maybe I've built a deck of cards object. So I've got an internal list of generic type card. That's my collection of cards, right? Trying to think through just a simple example to tease out this question. Would you do a pattern match on the card type? No, I don't think so. But if you made your deck of cards, if you made your card deck of generic type T, because you have different types of cards, you have pinochle cards, you have poker cards, you have Pokemon cards, and you wanted to do a pattern match on poker cards versus Pokemon cards or Yu-Gi-Oh cards, I think there's someplace else that you could better do that, right?
It's a really interesting question, because I think to some degree it doesn't. I mean, if you're trying to ask whether is this thing a list of T, then I think that is an interesting question. I don't think we support that. If you're asking whether it's Pokemon cards or Pinochle cards, then I think you could do that today. I don't know where a generic would come into that. But I have to use this every time I have. We lost me. Okay, I'm back. Okay. Is it, if you have an idea and you have a use case that really helps us out to understand why you want something, then put it on C# Lang. You can look for a issue already open. If there is one, add to it, ping it. Let us know you care. Don't just say, oh, it's there. I don't need to do anything. At least give it a thumbs up, because we really need to know what you want. We absolutely use that. We can't always respond as much as we want to. Somebody asked about unions. No, we don't have discriminated unions yet, but and they won't be in C# 12, but we're still talking about them. And unions have very special challenges to do it in a C# way. And I know everybody says just do it like X. Unfortunately, there's more than one X. And so we can't just copy anyone else's, including F#. We want to make it truly the C# way to do it. And we're definitely made progress in the last year. And you can track that at C# Lang. So that's GitHub, .net, C# Lang. But yeah, we don't have that one yet. Sorry.
Yeah. Okay. And since you all both really harped on, and I did too, pattern matching, the other feature that I think has really changed a lot of how I do development recently is the addition of records both record classes, record structs.
Sure.
Means for those things that are just data, or almost very little behavior, and I definitely want value semantics. It's just so much easier to just write that one line. It's a record of these things, and that's it.
Right.
I love records as part of a view model that I might be passing through an API.
Right. Yep.
I don't care about any other syntax. When I receive that object coming in on a post, drop it into a record, send it over to Entity Framework Persisted or through Dapper or whatever.
Yeah.
I love that. And sending the records back out, I don't care. New record, right? I do some sort of projection into that record type and send it out. I love it. You're right, Bill.
And the key word there is value semantics. So it's the value equality that it gives is the major feature that we get. There's a few other things that comes along, but that's really the big thing that we get in records, because they can either be classes or structs. There's other things that vary there, but the key thing is that you get value equality for free and the things that go along with value equality. That's the big one.
Yep. Okay. Other topic that I think is part of this, Felice Nabel. As a brownfield developer, I'm privileged to get to maintain code that uses every C# feature from version 1 upwards. I do too, and all the docs about it.
I think it's interesting. Somebody commented in my Twitch stream earlier today, complaining there's so many features that have been shoved into C# that they're just not all needed. Or we can do without them. And I look at that and every programming language that's being actively developed is getting new features. There's new features being added to JavaScript. JavaScript's been around 30 years. There's new features being added to Go. C++ got a garbage collector a couple years ago.
Yeah.
Right? Like,
yeah.
New
so I think it's a really good point. And there's two sides of that. One is that we do truly respect and love the developers that have code with C#1 syntax in it. We kind of hope it's really like C# 1.2, C# 2, because we think you're just in too much pain before that. But starting in C# 2, we had a solid language that could get the job done. And if that code is out there getting the job done for you, then we're not going to break it. Sure. And so we're not going to take things out of the language, even though there's people who wish we would. We will help you understand what to focus on, but we're not going to go take things out of the language. Okay, so that means inherently, when we add new stuff, the surface area gets bigger. And we actually do think about that. But we add things for several different reasons. And one of the things to keep in mind is that .NET goes way faster than it did 5 years ago. And it does that partially because of the language changes we did to support the people that do high performance work for you. And that's the compiler and the runtime and whoever else wants to jump on the bandwagon. But there's a lot of features we've added that almost no one outside of library authors, hardcore people that run benchmarks and really care and respond to that. There's a set of things around span. All of that work is designed for that scenario. And then you may pass a span through what you're doing, but you're not making those big decisions about how to make that work. And we have another one coming in C# 12, I think. I think we're doing a rough read only thing. So we keep expanding that, but you can ignore all of that. That is not, we do features in every release that is to move the needle forward, not for everyone to use. And that's a really important distinction. And Bill and I talk a lot about how to help you see the difference. And we don't have all the answers in that yet.
And I think there's a few different things there. I think that the feature you're thinking about for C# 12 that we're adding in that same kind of space is inline arrays. To create.
We're adding another one as well. We're adding two. Yeah. The other one's not released yet. So you haven't written it up.
Okay. And I think there's a great analogy that I've started to use a little bit where I talk about this in terms of playing music and an amateur guitar player. And if you learn like 2 or 3 chord forms, what an E chord looks like, what an A chord looks like, and you learn how to move them up the neck, you can play almost every rock song played, as long as you know where it is. But you're doing some pretty basic stuff on it. But you can get passable that people will recognize on just about everything. Now, you're not going to play some of David Gilmour's or Jeff Beck's solos or some of that. There's a lot of intricate stuff that you don't have yet. But even those guys, they didn't play their most intricate stuff all the time, right? You get the stuff that makes sense, and then you hit the things that work, and then you sprinkle in some of the other stuff every once in a while. And then it's like, oh, wow, that note sounded really cool there because it was just right over this chord kind of thing. And that's kind of where some of the features in C# are. There's some things you're going to use every day, all the time, that just is in your toolbox everywhere. And then there are some things that, depending on the domain you're in, you're going to use every day, but a lot of peers in the C# community won't. Like maybe you write games and performance and refreshing the screen and moving characters and being able to do certain things in a very high performance way matters a lot. Or maybe you're doing mobile and making a very small app matters a lot. And then you kind of go back and forth, but there's others. And like, as Kathleen says, our runtime team, if you go back and watch one of our older streams with Stephen Tobe, he talked about doing searching in strings, and the algorithm they use is really complicated and shaves like very little off of one comparison. But that API is used by so many millions of developers and so many apps everywhere. It's a significant thing all the way up. So there's different people we're trying to reach with different features. So the ones that you want to use that feel natural, dive in and use them.
Yeah.
See, but as an everyday web developer who's writing either services that are running as Azure functions out there, right, or building a website that's ASP.NET Core and interacting with some data to present on screen, I'm not even thinking about these low-level optimizations because I'm just using the framework. And you know what? There's other things that I can optimize first before I even get to, well, am I parsing this string efficiently enough?
Yeah.
Right. And that's what I really appreciate about the work that's being done on the language and on the runtime is that I'm at a layer of abstraction above, and I get those performance things just made available to me. And if I really wanted to reach in and tweak those, I could. But if there's one thing that Jeff knows is that these folks over here are a heck of a lot smarter than this guy right here. And I trust them with establishing that baseline. Okay.
We are good friends. We are good friends. We are friends.
And this comment, I think, is also a really important one. If you're starting to do things like that, you have to be measuring what you're doing before you tweak anything.
Yeah. Oh, yeah, don't
otherwise
touch it.
you're guessing.
Yes.
And yeah, it's and those kinds of things are important. And again, if it is a problem, then it makes sense.
And RGC is so good, man. We've had this like quiet background process. It's been going on now since, if not for 20 years, 23 years, about making GC better. And Mounty Stevens and other folks that work on that are absolute wizards. Mounty's been on the show before, I think, and they just are quietly making it better all the time. And it's amazing. Unless you measure a GC problem, you don't. And even then, you don't have a GC problem. You have an allocation problem. And that's almost always the way your code is written. You don't need stack alloc. We need stack alloc when the library needs to do something and needs to not add to your load. Your load is probably not giving you a problem. The thing is that if we go and have 10 stack allocs for every string comparison you do, that would be horrible. That would destroy the memory footprint of your application and what it's doing in memory, cause all sorts of GCs. So it's really important that these things you use all the time have as little allocations as we can possibly get away with it. And that's where stack alloc really matters and why your code just gets faster. You know, if you're running an application that you ran 5 years ago and you made no change to it at all, and you recompile it in a new version of .NET, it should go significantly faster. than it did 5 years ago, just by upgrading because of all that great work. And I know Jeff blames me, and I'm happy to look smart. Great, no problem. But no, it's not me. It's really smart people on the runtime and the languages compiler team. It's, I work with them, and I work with the ideas and how we decide what to do next. But other people, they won't let me do the code. So
yeah. So I think there's a really good comment here. I think that has a lot to do with keeping up. From Final Stack. I usually learn my code the way I've learned it a long time ago, and Visual Studio is smart enough to suggest how to do it the new way.
Yes. It's so cool. If you watch those little light bulbs and you're a light bulb fiend and you always find out what it is, and if you don't like it, fine. But Control Z works great. Okay, you never have to keep it. But if you just hit that light bulb all the time, you'll find out so much about how your code can be smoother and better.
Mm-hmm.
I love it. Hey, there was one in there about C# 12, and I can't remember exactly the way it's phrased, but about C# 12, what's the big feature? And
I'll find that one and pop it back up.
Yeah, it was way, I don't know if you find it or not. Oh, good. Okay, so you haven't seen yet the feature that I consider to be the biggest, most exciting feature for most devs in C# 12. In my opinion, that is something that's called collection literals or collection expressions. We're having a meeting on Monday to kind of get the name right, but it's going to be a simpler way to do the creation of any collections. So arrays, lists, anything like that. We don't have a sample of code ready to show you, but to tell you that there is a real drop in the DOM overhead when you create a list or an array. So that is the feature that I think everybody who's seen it has, it makes them smile. So I like features that make people smile.
And then I just dropped a note in chat to the language feature status page where you can keep track of which things are already merged, soon to be merged, or in progress at this point, or what things we're thinking about.
Yeah, and the in progress things will not all make it. But I don't see any reasons that I think I'm comfortable at this point thinking my best guess is collection literals will absolutely make it, and I will cry very big tears if it doesn't. So yeah.
Because we expect to hit a release candidate for .NET 8 here in September.
I think
that's when we usually see it. So we have 2 release candidates before release.
Yeah, so we have one more preview cycle, and then we'll have 2 release candidates. And we're already starting about, to think about locking down and think about how to stabilize and make sure. There's a lot of focus already on making sure that things work right, because we want RC to be like, we don't want to know there's bugs in RC. We want to be solid when we get to RC. So yeah, so we're heading that direction, and I'm excited for this release.
So trying to find some of the next ones.
All right.
Actually, yeah, this might be one of the most pertinent ones with what we're looking at right now. And then
what? So stuck in .NET Core 3.1. What features do you have in .NET Core 3.1 that you're having a problem upgrading? Because it's .NET Core through .NET 6, .NET 7 is pretty backwards compatible.
Yeah,
there's one or two places where it's the same ones every time, where you're going to run into issues, and it's going to be things around authorization and in ASP.NET applications. But yeah, I'd love to hear more about that scenario.
Yeah, that one we'd probably like to know more. Probably one of the best things to do is we do have pages on docs to go through the upgrade scenarios. If you add an issue there with some details, or go to the Microsoft Q&A site, which is just like docs.microsoft.com. There's a Q&A at the top, and put something in there with some of the details, because that should be really straightforward, once you're in the .NET Core stream.
Unless they're using binary formatter.
Yeah, that's true.
Yeah. Okay, everybody go run and hide.
Is Barry hiding here?
No, Barry's not hanging out with the dog here. So no. But so there are a couple of things that definitely they're kind of a little specific, but if you're in that world, yes, we're sorry, that binary formatter had to go. So, and I don't know if it was 6 or 7 where we finally pulled it, but that might be one of the things that they would be looking at. There's a couple of things like that that could be a problem. Yeah.
Mm-hmm.
It's not exactly binary formatter has returned. So yeah.
No.
That's different.
That is different.
This makes us sad.
So Ramphos, what I've been pushing more towards is, instead of writing functions directly with the function runtime, write a command class. Write a command class with an execute method, and instead of calling your code directly, instantiate the command, pass through the information from the triggers into your command, and command.execute. Then you can still reuse that command class, drop it into that administrative user interface that you want, where you want to be able to rerun an API. You want to be able to repost something. That little bit of refactoring that you can do then makes porting and taking those commands to the next version of .NET, of Azure Functions, a heck of a lot easier. You're still going to have issues wiring things up because of how they changed the request model, how they've changed the HTTP context model, how they've changed the way that timers and things work. They might as well not have called it functions, because it literally doesn't work the same way. But moving and giving yourself a layer of abstraction is going to give you that portability in your code. And I learned that the hard way.
Yeah.
Mm-hmm.
I mean, it took me 2 months to migrate an application from .NET Core 3.1 to .NET 6. And that should not be.
Yeah.
Menels, I'm not sure I said that correctly. The question on how do we figure out what goes into new I don't think we're going to get deep on this, because Matt Strogerson went through this in one of our stand-ups last year. I don't have the date. I don't know if someone wants to try to find that, but Matt's came in and gave an in-depth discussion. So let me give you a shorter answer, or maybe Bill could. We're both on the language design team, and we meet up to 4 hours a week. And it's a huge investment in time. I don't know, Bill, do you want to take this one and talk about what we do? Okay.
Because I was thinking about this a bit, and I'm going to say there's probably 3 different audiences for what you want to look for. If you look on Docs and the What's New in C# page, I will keep that updated with features that are in the latest public preview. So the latest version of that right now will tell you what's already available in a public preview in C# 12. Or, I sometimes get ahead of what's out in public, so it's there in public, and it will say this will be in this Visual Studio version. If you want to participate in the discussions, there's 2 places I would look. In the GitHub C# lang repo, which is github.com/.net/C# spelled out lang. There's a proposals folder that has all the proposals that are being looked at. Okay, so that means they may be just being talked about, like unions right now. We've got some designs, but there's no real code. They may be already merged, like the enhancements to name of. They may be almost merged, like collection literals. And to get up to the date information, there's another folder in that same repository called meetings, and that has the minutes of all the LDM meetings. And in each folder under there by year, it will say the agenda for each meeting. So you can quickly kind of see just skim that will give you what we've been talking about in those meetings. And
there's 2 more. So also, if you type Roslyn feature status, now we're going to switch repos. We're going to go over to Roslyn to see what's actually there. And you can just use your search engine, Roslyn feature status. You only use 1 S. I think the one near DC uses 2 S's. But for Roslyn, check that out. That'll give you a lot of information. Bill mentioned it earlier. And then the other thing that's worth mentioning is that we do blog posts when we have kind of got enough. We don't do them on every preview because we don't always have enough to be interesting. But we did just put one out recently, and that'll tell you what came out. But really, the canonical place for most people is going to be what's new in C# 12 in Docs. That Bill does a great job of keeping up to date. And he doesn't just smash all the information right there. If something is relevant in some other parts of the docs, then it just links to that. And that way you see things in context. I talked about the arc of collection, about pattern matching. How awful would it be if you had to go through what's new to find the different features of pattern matching? All the features of pattern matching are primarily documented under pattern matching. So anyway, I just like to brag on Bill because he does a great job.
Yeah, so just to really briefly elaborate on that, when I get one of the features that gets merged, basically I look at the docs and see where I have to change it, and then I write the paragraph in what's new to point to all those places. So the hope is just by looking through the things, you get the right view of how the language will work. We have a couple questions on one of our more in-depth, newer topics. So first we have this one here.
Yes.
And I'll let Kathleen start expounding on that, and then we can get to the second one.
Yes. Okay. So AOT is ahead of time compilation. If you're a long time .NET programmer, you're going, what? We were so proud of JIT back in the day, which is just in time compilation, which is great. And there's a place for both. Still, JIT is going to be the best thing in an awful lot of cases. Okay. It's still a really good strategy. Just in time compilation, what it allows you to do is write code that can then be run on a variety of different runtimes. So it can run on Linux, it can run on Mac, it can run on whatever you want it to. And that's really the value proposition of JIT, is that we go to a common IL, and just when you need it, it creates just the code you need. But the downside of that is that you ahead of time compilation allows you to get that already ahead of time. And there's two big benefits of that. One is startup time, it's startup. And the other is actually size. And the reason is that if we do all that ahead of time, we know all the stuff we can chop out, chop, assuming that certain rules are followed. And those rules are include not using reflection. And that's something that is coming into play. And source generators are a huge part of our process of getting rid of reflection and making code friendly to what's called trimming, which is throw away the stuff you're not going to use. And that is important to AOT. So that's kind of the big picture. And so I want to see if Bill or Jeff want to add to that before I make any comments on the future of source generators.
Yeah, I'm gonna make two because of why AOT matters at all. And there's really two scenarios where it makes sense. One, we talked a little bit about mobile devices.
Right.
And if you're running an app on a mobile phone, you really want to optimize for size. Yeah. And you want to optimize for battery life. And doing a JIT compile every time you start an app, well, that's going to affect battery life, and it's going to affect the size because you're loading your program, the IL, effectively into data, and then JIT compiling it into actual executable pages. By doing AOT, you skip those steps and you skip that work. The other one is containerized apps. So the smaller you can make a footprint for anything that you're running in a container, the smaller you make those containers, and the more containers you can put on a single VM, and so on and so forth. And you're saving yourself space and gaining some performance in those kind of server environments where you're running a containerized app. So those are the big reasons why there's a lot of optimization going on to really try to shake the trees better and get more of the code falling off so that you get a smaller image when you're running in those environments.
But there's two sides to the container discussion, Bill, and you make a good point of, I want to deploy a container that has a small runtime with a small instance of my application so that it does JIT and it's very small to pull and deliver that container. But the other side of that might be a consideration also, where you may want to do the ahead of time compilation for the container so that, okay, you know what, you're going to take a couple extra meg in size, and deploying that container might take a few extra seconds to deliver, particularly if you're pulling it from way across the network. But if you're pulling it from the same network segment, or you're pulling it from within your servers, those extra few seconds go away because you're running on your own controlled network. But if you ahead of time compile, where it might take a half a second to a second and a half to start, well, now that goes down to a quarter of a second to start because it's ahead of time compiled. Now we're talking. Now it gets interesting. So to exactly the point of, which one meets your needs.
Right.
And that's where architects can start to tune and figure out which one makes sense when you're in a container type of scenario. It's very interesting.
Right. And measuring there at that point too.
Yeah. Oh yeah.
Right. And it's also, if you're running several copies of the same app on a container, you want to run multiple different apps in different containers on the same VM.
Yeah.
And all those things will play in.
Yeah.
So as we get in, did you have more on source generators or
there's another comment.
Okay.
Fuel has one about F# and VB and source generators, and so it's a 1040 if you catch that one. 1040.
Okay, scrolling up there. There we go. That the one you want?
Yeah, it is. Okay, so source generators are Roslyn based, and VB fully plays. However, most people are not writing their generators for VB because they don't know VB well enough to be comfortable doing that and supporting it. And so it's sort of a secondary matter, not a not a primary matter, because VB it plays equally in the source gen space. So if you know anybody who's doing a source generator, you can ask them to do one for VB. But because they actually have to create the VB code, and we don't have a good way to do both, I have prototypes, but I don't think they're going to go anywhere. F# has an entirely different model to compilation and a different approach to a lot of things like high performance and that kind of thing, because they were way out in front. Remember, they had async like 5 years before there for the rest of us. So they're way out in front on some of the performance stuff. So they do some things differently around inlining. And they are working on AOT, by the way. And so F# will be trimmable. There is some fundamental problems with F# in the things like there's the way that the canonical way that you originally did console write line in F# was formatted using reflection. And so there's this base thing that can't be there, and instead interpolated strings replaces that quite well right now. But we have this process of getting F# ready to be fully trimmable. Great strides have happened in the last year. I think we probably have some more work to do to get that, but F# in a completely different way will become trimmable. But right now it's just being able to trim the F# runtime and the F# pieces of the story in order, and things like this, how are you going to just write something out? What's your printf statement? Those kind of things are going to get changed and fixed up. So source generators are still, we talk a lot about them on F#. We talk a lot about what we need to do to live in a source generation world. And we don't have the answers yet. So yeah, that's the most honest I can be about the F# side of the story.
So since he had a follow-up.
It does not. That's the short answer.
Okay.
It makes me sad. Tears. Yeah.
And then one more on AOT related for it. I'm not sure I have a good answer there. I don't know if you do, Kathleen.
I'm going to Jeff. If he's got this, that'd be great, because I don't know much about WebAssembly except, high level what it does.
So with the WebAssembly stuff, when you do deliver and you do AOT, you're also doing AOT on the entire framework that you're delivering into the browser. So it's not just the little bits that you're deploying, but the whole enchilada. So it does make it bigger because it's got to run inside that WebAssembly runtime over on Blazor versus native AOT, where we've already got some of these components shaken down pretty well inside the runtime. And I believe we're able to do that better, faster, smaller on what's going to end up being an AMD Intel processor or an ARM processor. So instead of the virtual machine inside of WebAssembly, if I believe that's the discussion that's happened around that.
I don't know. So you should take that with a grain of salt.
Yeah,
None of us are experts in this space. And maybe we'll get somebody who is on the show coming up. So yeah.
Okay. And then we have one more topic to go to. So we can start with this one.
Interceptors. Interceptors, experimental feature. We don't even know if we're going to keep it. Okay. But I got to be really clear on that. But if we go back to the regex example, it makes you able to do regex the way you used to do regex instead of requiring an attribute. That's the value proposition. There's a bunch of other places that are like that because instead of you having to tell us that something extra is going on in order to get the generator in place and us having a method that we create for you, you don't have to have a new method. It just takes the method you calls and said, we're going to do it this long fancy way that is going to make it go way faster as opposed to the traditional way. And that's what an interceptor does. They're experimental in .NET 8 and C# 12. They will remain experimental for the entire cycle. They're being released in preview in GA. So I just need to be very clear on that. We have ways that we're using them and experimenting with them internally, but that's because our internal teams can take the pain if we make a major change or remove the feature. So if people want to play with them, give us feedback, that'd make us so happy. But do it in the context of there's no guarantee this feature is going to stick around.
Yeah, and definitely, Shreyas, add to the discussion. That is definitely valuable, and especially if you have a different approach to the problem.
Making an absolute statement like that with no details, that means nothing to us to say it's not right. Okay.
We do have feedback. We do have feedback, exactly. And somebody may have already articulated the direction you think, in which case go, either gives it a thumbs up or go and add more information for us, because we did this feature a way that has some simplicity in its concepts that we kind of like. But it's definitely not a space that if we have settled, we wouldn't be releasing in preview. It's not a settled space.
I've been thinking of the interceptors feature almost like compile time DI. Instead of runtime dependency injection, it's compile time dependency injection, and you're able to swap out specific parts of code.
From a logical point of view, that's correct. Although from the way it looks on the page, it may not be correct. For example, the way that we call a method that we're intercepting may not actually look like anything that it could be a static method. Okay. So it could be something that's quite different than what you would expect to work well in a DI environment. So yeah. So other than that, yes. I mean, it is the same kind of thing. On the page is this, and we're going to call that. It also is part of the compile. So it's not this or that, the way testing like if you were using DI for mocks or something, it's not like that, where you might do this and you might do that. It is, I've got a generator, that generator is going to do this thing, as far as I know, because otherwise you would have to have the generator generate code that could tell the difference. And at least on all the scenarios we're working on, that would hurt performance too much. We wouldn't do it. I don't think we'd ever do that.
I was under the impression that it injected code at the specific line in location.
It does, but it's when the generator runs, it establishes the code, the single set of code. And so like in DI, I could at runtime, I could switch out what was in my container, and I could run different code at runtime with the same compiled code. You cannot do that. We're compiling down to the code that runs.
Right. It's dependency injection at compile time.
Okay.
I think I think dependency injection honestly is not a helpful abstraction.
Oh, okay.
Okay. So I'll give two scenarios, it's probably three, but I'll give two scenarios that make a lot of sense on here. So Kathleen already mentioned the regex ones. Right. So maybe I can look at a regex. I can go, you know what? There's a really efficient way to just do this comparison. I'm going to replace your regex, which is a runtime comparison of a regular expression, with some other search. Okay. So here's two others. If you look at an ASP.NET app where you're going to wire up controllers, map.get, and here's a delegate for this one, here's a delegate for that one, here's a delegate for the others. With each of those, the way you would normally write it, the compiler is going to create a delegate object, and we're going to then call that thunk through the delegate pointer at runtime.
What's a thunk?
It's basically just like a function pointer, right?
Okay.
So it's going to go, we have an extra indirection there. A generator or an interceptor can go, okay, I know what this thing is doing. Just call that method directly that's on the right-hand side of the delegate and get rid of that extra indirection. A little bit faster. Another big one is consider something like entity framework. Okay.
Mhm.
So you write a link query, right? So it's all this C# code that does some kind of query into your database, and from C#3 on, that gets translated by EF into a series of SQL statements.
Yes.
That then gets executed, right? That translation happens at runtime. Now, suppose a interceptor and a source generator from the EF team could go, aha, I see what this query looks like, and I can replace a lot of it with parameterized text SQL at compile time, right? So now what happens is, instead of doing that translation at runtime, every time you make that query, that translation happens at compile time and it's burned in your executable. Okay. So in a way, an interceptor is more like the compiler now through interceptors that are specific for a library, recognizes certain constructs and writes better machine.
So I want to challenge that last little example you had.
Yeah.
Okay. So entity framework is generating and it's pulling together. Here's the SQL, and we can generate that SQL and that interaction, and it gets written to disk. If at compile time you decide, you know what, there's a better, faster way to do this, why not just you do that?
Because we'll write bad SQL because we're C# developers.
See,
the library authors have to be in control of their expertise in their domain.
Right.
Right. And that's where I'm looking at compile time. I can't swap out content in entity framework as an end developer.
Right.
I can't inject and change that. But I can, in my repository method, say, you know what, at compile time, when we're going to build and deploy and send over to this location, swap out the implementation of that, so it's now this.
Right.
Right. That's where I feel like there's where the oversimplification is, it's like dependency injection. That's
right.
That's the hand wavy, right? The elevator pitch. Absolutely. There's a lot more underneath there. And I struggle to figure out what's going to be the right places to drop that in. AOT feels like a good example, to be sure.
Right. Right. And again, I'm not sure, not all of these, and because of some of the comments with my last example, that's a hypothetical example, right? Nobody's written that yet.
Right. Right. That's why we're an experiment.
But it's an idea that we want interceptors to be able to support. So going back toward normal stuff, I have two really good follow-up questions toward the end here. First one on, since we've talked about, like, how do you keep up? How do you know what the surface area is? What about a feature flag to use only recommended Lakewood features and hide some of the legacy stuff that we shouldn't be using anymore?
So, Bill, I'm going to let you take this one because you think a lot about this problem.
So the first answer I have for you is, for your team, really look at a thorough editor config. That will do a lot of things to recommend certain usage and give you analysis warnings when you step outside of those bounds. So if you go in Visual Studio, if you search on the command palette for editor config, it will give you all kinds of rules for C#. Everything from style, like where do I put braces, to can I use var, don't use var, can I use async, can I use ref keywords, all kinds of things that you can say that if you step outside of these bounds, you'll get warnings. There are also a large number of other code analysis rules and other community written analyzers that look for certain features and either offer suggestions for changes or will give the equivalent of compiler warnings if you're using features that are just, they're back there and we still support them, but you shouldn't be writing those today.
You can dial those warnings up to errors if in your organization you don't want to use it.
Warnings is, so we say compiler warnings. It's one of those places our technical speak falls into the real world, because a compiler warning can have different levels. It can be info error or warnings. So compiler warnings are not restricted to staying warnings. You can go into your editor config and you can make things errors. And I highly encourage people to do that. And you can, I think you can also layer up the file hierarchy on your editor config. So if there's a small set of things that everyone in your organization should do no matter what, then you can have those. And then if down on this project is legacy, it can't handle some of these rules. This other project is not legacy, so it can handle these rules. And so I know it's some work, but I really think this work pays off. And so if you just imagine what would happen if we decided we had to decide on recommended, the arguments that would ensue internally and externally. And we also we never want to make it like this is cool and this is not, because then we don't want to say you can't do C# the right way. We don't ever want to do that. So we really think the right thing is to say that what is recommended for you is what is recommended for you. And if we need to do more work on getting some editor configs that go along with every release, we'd consider that. But mostly we just turn those warnings on and let you figure it out and turn them off if you need to. And, do you have something else? Because there's one I wanted. Okay, and then there's one I got after that. Here,
which wrong one. I wanted to show this one. There we go.
That's the one I wanted to show.
I thought you would.
Okay, great. So one of the things I want to say here is a shout out for the fact that we should have Chad Husk, who is also one of our hosts, who will be our guest. He'll be the same, talking about the CLI, talking about changes to workloads, to changes to the build output, which is beautiful, and changes to some other things within the CLI space. So yes, there's goodness, and all the compiler stuff we're talking in the language, you get all that for free. So yeah, we've got stuff coming, and we'll be talking about that and containers with Chet in an upcoming thing. I don't know, Jeff, have you seen the new build output?
I did see a little bit of it.
What do you think?
I got to get used to it.
Okay.
I don't know, right?
Okay.
Changes like that, and I haven't spent a lot of time with it. When I demonstrate things on stream, when I show new features, until we get to a release candidate, I don't show the previews because we know they're going to change. Okay. So, totally so I'm practicing and getting up to speed on some of that stuff over the next few weeks, and then we'll roll that out when we get through August and talk more about it. So,
all right. Well, should we put Jeff on the spot and let him tell us what he hasn't had a chance to stay coming here to visit us today and move towards closing out since our time has run out?
So I'm sorry, what's the question?
You get to close this. What do you want to say that you haven't had a chance to say yet?
I'm such a huge fan of the language of the C# language. You know what I'm saying? I think there are folks out there who want to add all the things into the language, and there are other folks who say, "Gosh, it does enough for me. Stop. We don't want to add anything more." And I see the reaction to how we've paused, and we're being very deliberate about what we're adding. We've paused, right, experimenting and adding new development into Visual Basic, and I think it's an interesting. Right, it's an interesting community that we live in, where there are folks who have a paused language, and they don't like that. Right, where we're getting very deliberate new features being added, and we have one that's on high speed, and we have lots of great new features, staying very innovative, and there are folks saying this is either too fast or you're adding too much stuff. Like, well, which one do you want? Like, we're literally giving you everything, and you're not really committing to one or the other. Have I tried other languages? If yes, which ones? I've programmed. I program a lot in JavaScript. I program a bit in Python. Not a fan of Python. I've programmed a bit in Java. I've built a couple of Android apps in my past. But why, when I can do everything in C#? Like, why not? The big thing, and I want to ask Bill and Kathleen this. The big thing that I see folks clamoring for is, oh, we need discriminated unions. Discriminated unions is the thing we need to make C# complete. And at the same time, I look at that and I go, you have a dynamic keyword.
Oh, no. It's the
No.
opposite.
No. Hang on. Let me finish. You have a dynamic keyword that allows you to basically define and work with any type, and then you have to do your inferring. But you want to break the ability for C# to be a statically typed language a little bit by saying, well, this type can be either or these types of things, which kind of, in my mind, kind of goes counter to the whole purpose of a statically typed language in the first place. So that's where I'm looking at the clamoring for discriminated unions and saying, you don't really want C#.
Well, let's look at it this way. What
And tell
if we
me where
made
I'm wrong there. And
Okay,
help me
let's say-
understand better.
Let's just say we made a new thing. This is not what we're going to do for discriminated unions, but I think it's a good way to explain it to folks that are not, that are not quite, I don't know. Let me tell it to you this way. Okay. So what if we had a new type and it was just like an enum, except it was restricted to those values. You couldn't put in a bad value. You had to have one of those values. You like that idea, right?
Well, we already have that capability.
No, we don't.
We don't.
We absolutely do not. You can put any value in the world into an enum.
No. I was going to an abstract class.
Sure.
So, but an abstract class has an infinite number of derived classes. You have no way to control that. So that's another great way to say what we want to do with discriminated unions. And we're not sure how we're going to implement it because it is complicated. And another thing that you might want is if we're able to restrict enum values to a given set, then wouldn't it be nice if those could be any type? Or particularly, they could be they could be strings. We could say restrict this to this set of strings. And so this is the exhaustiveness is is the word we use for that. And that is one of the high things. That's a bit that I don't think will release discriminated unions unless it has exhaustiveness. I think that's there's a lot under that that's still in play, but I think I think that one is going to stay.
So to put a real example on this is if you look at pattern matching with a switch expression in C# now, you often have to have something at the bottom with like discard and this is bad, because if you don't, you get a compiler error that says this switch isn't exhaustive and doesn't handle all values. And it's like, I handled all the values of my enum. And as Kathleen says, well, no, you didn't, because they could put anything in it. And the same thing would be true if it's some abstract class, which of the derived classes, well, it could be something else that we don't know about. And we actually those kinds of problems, a discriminated union would be, this is, say, a dice roll. The only numeric values valid are 1 through 6 on each die. And that's it. And you don't have to have that extra, well, somebody coded it wrong case at the bottom. And that does come up fairly often. So there are good reasons to keep trying to get this in a C# way that really solves those issues.
And we have one case that we have something very close to discriminated union today in C#, and that is nullable value types. Nullable value types are either a value or they're null. And we work with that and we like that. And so I do think that those kinds of things, but now we're talking, all of this conversation has been very F# style discriminated union focused, which is one representative of one style. We haven't been talking so much about the TypeScript side, which is a different kind of way of thinking about discriminated unions. It is marrying those two as part of our challenge. So, because they both have good features. So yeah, that's why discriminated unions are hard.
Okay. And
see, I'm so used to just I can handle anything else got jammed in here, who cares,
right?
And it's like, so what? So,
but
all right,
it's always a mistake in your code. And what if it could catch it at compile time? So what if the fact that if you put a 9 into something that didn't take a 9, you saw it at compile time? Wouldn't that be great?
Sure.
Sure.
But that's why we have things that could generate unit tests that test boundary conditions and other weird things. But you're right. So
and we have gone a bit over, which
we did. We went way over.
We had great questions, and Jeff has been a fantastic guest.
Yay! Thank you, Jeff.
Thank you.
With that, had some ideas for some follow-up future ones. And I want to thank everyone for being here. Oh, wait. Go ahead.
There's folks asking questions about cloud native. I'd encourage you to bring those questions to the ASP.NET Community Standup on Tuesdays. They can help with those questions. Then this is more language focused, not framework focused.
Mm-hmm. Right.
And runtime.
Yep.
And runtime. Let's not forget the runtime. Yeah.
So.
All right. Well, with that, Jeff, are we ready to say goodbye?
I think so.
I think we are. All right. Goodbye, everybody. Thank you so much
everyone.
for joining us today. And
We'll see you.
Enjoy the rest of your evening or your day.
Hey.